Hello folks, today we are going to discuss decorator design pattern. In this series we have already discussed optional design pattern and signature design pattern. Today we are going to discuss this pattern. I have heard about this pattern very much, and we are already using this pattern means in our HTTP middleware, and also if we are writing custom encoder decoder, there also we are using this design pattern. You can understand this design pattern by a simple example. Let's suppose you have a simple coffee. You are ordering a simple coffee. You went to a coffee shop and you order a simple coffee, and then the folks will ask means do you want some addition? So you said let's put some extra milk. So when they put the extra milk in the description of the coffee, they will add the cost and also the description. So the simple coffee cost and now the milk cost also added to this, to the your whole cost. And now they will ask, do you want the extra sugar? Then you say, yeah, put some extra sugar also. And when you say put some extra sugar, the cost again changes from simple coffee to milk and then sugar. And also the description changes as per the requirement. So if you see, this is changing from basic requirement, a simple coffee, to there are two components that we added, the milk and the sugar. So this is how the decorator pattern works. Let's jump to the code, I guess. Means it will help you to understand this example. I have written a Go code. Let me go through that code. So if you see this example, I have coffee interface. Okay, this is the step one, and in this we are defining an interface which have two methods: get description and the cost. So in the get description, we are just, it's a getter method which is returning a string which is a description of the coffee. And again the cost is like what is the cost of your coffee. And in this is the step one that we need to do, and this is the step two actually, to define the things for your concrete component. Let's suppose for the simple coffee, what is the description? For the simple coffee only, the description is simple coffee, and what is the cost of the simple coffee is $1 only. Okay, so it is just an concrete component, you can say. And the step three is like you need to define the abstract interface, abstract class. Here it is class, but it is not a class. You can, for the better understanding, I have written that in this, why do we need this, and why can't we define the milk or coffee instead of this coffee decorator? We need it because sometimes it can be happen like for the milk class we don't want the description to change, so we can just skip this method and it is totally fine because of this abstract class, abstract decorator that we define. So I will show you the use case later. When I am going to run this program, you will understand why do we need this coffee decorator. Okay, let's jump to the milk struct. So in the milk, it is like just a simple like milk struct, and here we are like kind of inheritance, you can assume for better understanding. We have the coffee decorator. The exact terminology is composition. So we are composite a different struct which is like coffee decorator. Now this milk struct have all the properties that coffee decorator have. So you can call anything from the milk which is a property of coffee decorator. You can assume it like that. Here is the constructor that we define. In this we are returning a milk struct like this struct, and after construct, on this constructor you can we define the two method which we have means declare here, get description and cost. And here we are defining both the methods. So what we are doing in this method, what we are changing the description. As I said that in this the description will change, the milk will be added and also the price. So here we are adding the milk in the description and also the $0.5 price. So in the same way we define the sugar struct, we define the decorator and compositor decorator, and here is the constructor of the decorator, sorry, the sugar struct. And we define the description. In the description itself we already added a sugar milk, now we added a sugar also, and also the sugar price is $0.25 which is added to the base price. So let's understand how can we run this. So we define the coffee. Okay, it is a simple coffee. Okay, now what we do, we say, oh, hey, let's add the milk also. So we call the new milk constructor and we pass the coffee, simple coffee there. Now our coffee with milk is prepared. Now we say add some extra sugar also. So coffee with milk and extra sugar, and we pass in the new sugar constructor, we pass the coffee with milk. And now we are printing the price and description. So let me print it, and also I am go run dot. So if I run this, you will see the description is simple coffee. Simple coffee is the concrete class, means concrete component actually. So it is simple coffee, and milk is the new milk that we have added. It is a new milk, and then the sugar, and the price is 1.75 because uh, $1 is the cost of the simple coffee, and 0.5 for the milk, and for the sugar it is 0.25, so total is 1.75. So in this way we can build the constructor. In this way we can add any other method also. Let's suppose we want chocolate also. Let's suppose we can define the construct for the chocolate. We can, in the same way, we can define the means constructor and also get description cost also. So one more thing that we discuss in the when we are start this video, why do we need this concrete, not the concrete but decorator abstract class? Why do we need? So let's suppose in the sugar itself, we don't want to change the description. I don't want to change the description. I want like simple coffee with milk only, and I am not implementing the interface also. So in this case, when we are calling this get description, it will be called by this means concrete, not the concrete abstract class only. So it will call get description, which is called this coffee with milk. If it have, if it doesn't have, then it will call the coffee. So in this way it is like a in the same way interface work, like it will check for in this struct first, then it will check in this struct, then it will check in this struct. If it is available, then it will print. So let's print this time. If you see, there is no sugar that is printed. You see the price is increased, but there is no sugar that is being added. So this is how our decorator design pattern works. I will put this code in the GitHub and paste the link in the description. Please follow if you find this lecture helpful, and I will put more awesome videos on Go and the computer science, in general computer science programming. Bye bye guys, take care.